Hello YouTubers and 3D printing enthusiasts. So I'm going to talk about how I made this knob. This is a potentiometer and a little knob I made for it. You can see it's nicely knurled. Fits right there on a D shaft. That's what we're going to talk about. Back in Fort Wayne, I have a good friend of mine I've known for years named John. Hi John. And he was saying he has trouble with CAD. And I'm trying to think of how to show him that it's easy. And so this is a FreeCAD tutorial on making that knob. And John, it's easy. Let's go through it. Before I start making the knob, I'm going to look at this potentiometer that I want to use. And I want to make some notes about it. First off, it's a D hole at the end here. So I'm going to need to measure that diameter. I need to figure out how tall I want the knob to be, about like that perhaps, and how big around I want it to be. Probably about, maybe about as big around as the, about as big around as the potentiometer case. Would be a nice, diameter. So let's make some measurements here. So the potentiometer case is 28 millimeters. So yeah, we'll shoot for about 28 then. Knob diameter, 28. Making notes. Shaft height. The shaft height of the knob that's going to engage with this D is going to be, let's see, the depth of that is 7.5, so we'll go for 7. Shaft height, 7. Now this D, I'm going to measure from the flat side of the D to the outer edge of the shaft is 4 millimeters. And then the diameter of the shaft itself in this direction, and that is 6.4. Yeah, I'm zeroed. 6.4. Which is the diameter of the shaft. Okay, 6.4. Now I think I have the dimensions that I need to make my knob. Let's go to FreeCAD. Okay, here we are in FreeCAD. And we're going to start making our part. Now, as usual, we're going to start here in this parametric part under New File. And that's going to set us up. Over here on the left, we'll have the tree view of our model. This is going to show all the steps that we're making, and we're going to be renaming these features as we go so we can keep track of them. We have data, information on whatever our current operation is that we can modify or change, and a list of tasks that we are going to do. And the first thing we're going to do is create a sketch. FreeCAD tries to help you along by suggesting what the next option or tool you might want to use is. This axis cross, I have it turned on by default under View. Toggle axis cross over here. You can turn it on and off. I usually keep it on for myself because I kind of like having it as a reference. Some people don't like it and they turn it off. It's up to you. Also, I am designing in the metric system, millimeters. That is preference. I like it because it's base 10. It's easy to math in base 10 and not have to deal with fractions. But you can design in whatever format you want. Okay, so we've got over here in the tree a body for our part. Now we need to create our first sketch. And I'm going to create it down on the flat plane looking down the Z, which is the Y and X plane. Down here in the lower right corner you can see Y and X. So I'm going to come up here to the Create Sketch tool. It's going to ask us where we want it. I'm going to put it on the X and Y plane. And we're ready to start drawing. We're looking straight down. Now our knob is going to have primarily a big round shape that we figured out is going to be about 28 millimeters. So I'm going to start with a circle. And this is the circle by center. I want to start with the center point. And I'm going to use this origin point here, which is the coordinates 0, 0, 0. Whenever you can, if you're doing a single part, use that origin point because that will be very helpful for symmetry later on. And for doing things like polar patterns, which we are going to do for making this knob. So I'm going to click and I'm going to drag out and we're going to make our knob. Now I think I determined I wanted this about 28 millimeters in diameter, so 28. That is our first shape. I can right click to get my mouse pointer back out here in the open space. So this is going to be the primary part of our knob. Simple sketch. It turned green because it's fully constrained. It has the geometry is locked down to this center point. We've got a diameter defined. I'm going to hit close, and there's our sketch. Now we've got to give it some thickness, and we'll do that by padding it here. This is the pad tool in the upper left. So I'll click that. By default, it goes to 10 millimeters, which is probably a bit too thick. I think our knob should be maybe, well, I don't know. 10 might be okay. Let's go with 10. We'll go with that. If we don't like it, we can change it later. That's the beauty of a parametric program. Down here, pad parameters. Over here, this part of the window is always going to show us data on whatever we're doing, and we can make our changes here. We can change the direction of it. We can change angles, and all the data related to our operation will always be over here. So I'm going to hit OK because I'm happy with that 10 millimeter pad. And I'm going to come over here to the tree in the left, and I'm going to name this. Right click, rename. You want to do this as you go. Knob body pad. So as this tree builds, you can keep track of what is what. Okay, so we got the main body of our knob. We want it to be knurled. We want finger grips around the outside edge of it. So let's do that next. I'm going to click on this face to highlight it, and we're going to make our next sketch on that face. Okay, we're going to make our knurling pattern. Now that's going to be a kind of almost sinusoidal kind of swoop down, swoop up, swoop down, swoop up, swoop down, swoop up, all the way around. And the basic of that pattern is kind of a semicircle, an arc cutting in. But I'm not going to use an arc. I want to make this easy. I'm going to make a circle, and I want it to be tied to the outer edge of this knob, so I'm going to import geometry into our sketch with this tool here, which is, come on tooltip, there we go, create external geometry, create an edge linked to an external geometry. This lets us create a reference to something outside of our sketch, in this case the edge of this circle. You can see it highlight when I hover over it. I'll click, and then I'll right click out here to get my mouse pointer back. Now, if you can see it's a dotted line, I'm going to come over here to the pad on the tree, and I'm going to hit the space bar to hide it. Now it's invisible. The little eyeball has a slash. And now we can see this dotted line. The dotted line means this is reference geometry. It's not actually a physical part of our sketch. It's a reference to an external feature. So I'm going to make a circle, again with the center circle. Tooltip, there we go. And I'm going to put it right on this dotted line, and I'm going to put it, about there. We'll just pick an arbitrary value here. We're going to probably adjust it. Let's make it 5 millimeters. And I'll right click out here to get my my mouse pointer back. Now I want to lock it onto this vertical axis line. This is another reason for using that origin point for something that's symmetrical. We have a horizontal and a vertical axis line that we can use in our sketch. So I'm going to click on the center of this circle to highlight it. I'm going to click on the vertical axis line. They both turned green. And I'm going to come up here to this, which is constrained coincident. It's going to lock that point to that line. Click. So now that circle is locked to this line. And the reason I did that is we're going to be repeating this circle around, this cut around our knob. And it's just nice to have this locked to 0 on the degrees of our circle. Then we can measure things. Okay, let's see how that's going to look. I'm going to leave that at 5 millimeters, and I'm going to close. Now you can see our sketch sitting there, and we're going to cut that through this material. So I've got it highlighted over here in the tree, sketch 001. I'm going to rename that to, and I don't know if I'm spelling this right, I'm not sure, but knurl. Cut, I'm probably spelling that wrong, but that's okay, we know what it means. And I'm going to cut that through. I'm going to use the pocket functionality, and that creates a pocket using our sketch, but I want to cut it all the way through our knob here, which is 10 millimeters. Down here in the lower left, under tasks, here's our pocket parameters. Length is 5. I'm going to change that to 10 to match our knob. Okay. Alternatively, I could, let me bring that back. I could change the type to through all, which will go through all of the geometry above and below the sketch. Since we've only got the one piece, our knob, I can set that, and that way, if I change the depth of this later, if I decide that 10 millimeters is too thin and I want to make it thicker, maybe 20, this cut will still go all the way through, and I won't have to come back in and change it. So I'm going to set that to through all and hit OK. So now we've got our knurl, first knurl cut through there. We need to repeat it all the way around the knob, and this is where polar patterns come in. This is pretty cool, and it's pretty easy. First off, let's rename this from pocket to, and I know I'm spelling this wrong, knurl pocket. We've got that selected. All right, we're going to come up here to the part design menu, come down here to apply a pattern, and we're going to do a polar pattern. Now, this is another reason why we wanted to use that center point for our center. FreeCAD has already guessed that's what we want to rotate around, and it's picked well, it always starts with 2 instances, and so it's exactly opposite. We come over here to the tasks window to our data. We scroll down here, polar pattern parameters, and if I scroll down, there we are. We're going to go a full 360 degrees around around our center point, which is our normal sketch axis. Normal being the Z axis of our sketch, which is this blue up and down right through it. Occurrences 2. Let's increase that and see what happens. There's 3. There's 4. Let's keep going. Let's keep going. Maybe one more? Yeah, I think that's good. I don't know. That's 8. What does it look like with 9? I think I like that better. The width of this part is about the same as the width of my circle. And I think I like that. So let's go ahead and hit OK. And that is how a polar pattern lets us duplicate a feature around a pole. Neat, huh? Now you might be thinking, well, yeah, that's nice, but boy, that looks ugly with this flat face here, and we need the curve up here. Yeah, we're going to do that at the end, because we're going to use a feature, a dress-up feature, and I'll just show you what it's going to look like. We'll pick this edge, we'll pick this edge. Oh, I got to hold down Control to get them both. Okay, and if I come up here to the fillet tool, and then down here to our data, its radius is 1 millimeter. Let's increase that. Not too far. There we go. And see that? That's how we're going to do our knurl. At the end of the job, you always do your dress-up features last. We're going to do that to every single one of these all together to get our knurled pattern. But not right now. We've still got to make our shaft. So I'm going to cancel that. So now we're going to need to make the hole for our shaft off the potentiometer. And I need to sort of make a little circular feature that stands off a little bit. So we'll do that first. I'm going to select the face of the knob. It turned green. And I'm going to come up here to create a new sketch. We're going to create a sketch on that face. This is another example of why we wanted to use that center coordinate to start our entire part. This gives us this nice center point. I'm going to come up here to create a circle by center. And we're going to make the standoff. So we'll go with 10 millimeters. Nice thing about a parametric program, we can change any of these values later on. I'll just drag this out so we can see it, make it easy to find if we do need to change it. And I will hit close. And we'll come over here and we will rename this sketch to standoff sketch. All right, so let's give that some thickness off the surface. We'll go back up here to pad, pop it off. And again, 10 millimeters, probably fine. We'll start with that. We'll see how it goes. And I can tell by looking at this that that might be a bit too small. Let's say we make that a little bit bigger, huh? All right, so 10 millimeter standoff is fine, but I want to make this bigger around. I come up here to the pad we just did, and if I hit this little arrow to look inside of that pad, that's where our sketch is. So I'm going to double click that, bring it back up, and we'll change this dimension to 15 millimeters. That's probably going to be better. I'll close this, and you can see it automatically recomputed out here. Good. I think that's probably fine. Let's put what's next. Oh, got to rename this. I can hit F2. That's a shortcut for rename. And we'll call that standoff pad. All right, now the fun part. We got to make that little D hole for the shaft. So I'm going to put that on this face here. So I'm going to click on it to highlight it. And I'm going to come up here and say New Sketch. Zoom in a bit. And we're going to put our shaft hole right there. So we start with a circle, because the shaft is basically a circle. Again, bring it in here till I see that little coincident constraint up here. Little crossbar with a dot. And I'll click and I'll drag out. And release. Now the diameter of the shaft we measured as 6.4 millimeters. I need to make this a little bit bigger. If the hole and the shaft are the same size, the shaft can't go inside the hole because the walls occupy the same space. We need some clearance. So it was 6.4. I'm going to give it 0.3 of a millimeter, and we'll see how that fits. 6.7. If 0.3 is not enough and it's too tight, we can always come back in here and increase that later. So we'll go with that. That's the diameter for the hole for our shaft, except that our shaft is a D shaft. I'll come out here to open space and right click to get my mouse pointer back. So we need to have a cut, or a straight flat side right here. I'm going to make that with the line tool. Create line. I'll select that. I'll come up here and I want to connect it to my circle, so I'm going to move this up until I see the circle highlight. And a little constraint next to it there that says an arc with a dot. That is a point on object constraint. That means we're going to start by putting our point on this object. So I'll click, and then I'll draw my line down until I see it again highlight the circle, so I'm connecting to it. And next to that, you also see a little vertical line. That means we're going to be constraining this line to be vertical. Click, and there's our line. Now I'll right click out here in open space to get my mouse pointer back. What we need to do now is we need to trim out or get rid of this part of the circle, this arc. That gives us a new tool I haven't talked about before, right here. Trim edge. This lets us trim or get rid of an edge. So I'm going to move it until I highlight this part of the circle, and I'm going to click, and it's gone. We just trimmed that part of the arc. All right, right click to get my mouse pointer back. Now we've got to set dimensions. The first one we got to set is the diameter of this arc, or this circle, which I should have done when I was drawing it. Did I? I did. Okay. So we've got the diameter of this circle already set, but now we need to set the distance between this flat side and this end of the circle, which we measured as 4 millimeters. I need a point out here to set a distance to, so I'm going to add a point to this circle. Come up here to the Sketcher tools in the upper left, create a point. I'll select that. I'll bring it out here, and I'll move until I highlight the circle. And if I'm close enough to this horizontal line, it's going to lock the point on that line for me too. Okay, that's fine. So we got our point on object constraint here. We should be good to measure our distance from here to here. I'm going to select this point, and I'm going to select that point, because you dimension between points. Come up here to the dimensioning tool, and I'm going to constrain a horizontal distance. And you can see that's actually, in the horizontal direction, a distance between these 2 points. Not a straight line distance between them, but a horizontal distance. And we measured that as 4 on the shaft. So again, we're going to add some clearance. I'm going to put 4.3 and hit OK. Okay. That's our D-hole. That should be correct for the potentiometer's shaft. So we'll close this and we'll make the pocket for it. We got the sketch selected. It's green. I come up here to the pocket tool. Click that. And it gives us a default of 5 millimeters. How far did I measure that? 7? Yes. I measured that we wanted that depth to be 7. So I'll come down here to the lower left, pocket parameters, and we'll change that length to 7 and hit enter. And there is the hole for our potentiometer shaft. And again, I'm going to come over here to the tree and I'm going to name that because I might have to come in and adjust it later. So we'll call that shaft pocket. Okay, this is basically our knob. Now we've just got to clean up these knurls and maybe do 1 or 2 other dress-up features. So the first thing I'm going to do is I'm going to make all of these nice and curved. So this is going to take a moment. We got to select each one of these edges. I'm going to hold down the control key. That lets me select multiple edges, and I'm going to select each one of these that I can see. And then I'm going to release the control key so I can use my mouse to move around. Then I'm going to hold down the control key again, and I'm going to select more edges. And again, I got to rotate it so I can see the rest of these. Release the control key so I can move, hold down the control key, and add these edges. Oops, I added a face. No problem. I still got the control key held. I can just click it again to deselect it. All right, we'll select that edge, and we'll select that edge. Is that all of them? Yes, that's all of them. Okay. With all those edges selected, I'll come up here to the fillet tool. And there's our fillet started. Down here in the lower left for our data, we're going to go over here. Here's the radius of our fillet, 1 millimeter. I'm going to increase that. And I think that's about it, isn't it? Maybe a little bit more. If I go to 3, these 2 edges are going to cross and it's going to fail. Watch. Poof, it failed. We went too far. You can't cross edges with your fillet. So maybe 2.5? Yeah, there we go. That's good. What do you think? I think that looks good. That gives us a nice knurling. And now let's, what else can we clean up a little bit? To make it easier on the fingers, these edges are really sharp right now. So what I'm going to do is I'm going to add a chamfer to these edges here. Now if there's a connected continuity, like there is for these edges, they're all tangent to each other, so it's a nice flow. We only have to select one. Oh, you know what I forgot to do? After I was done making these fillets, I didn't hit OK over here in the tasks on the left. We're still in the process of making these fillets. We hit OK. There we go. Now I can select this edge and I come up here to chamfer. I could do a fillet here, but this is going to be laying on the print bed, and a fillet starts to curve gradually and then increases its curve, which means that at the edge here, the first part of that curve, we'd be trying to print over thin air and it would fall off and be ugly. But a chamfer is a 45-degree angle, generally. So that you can print. So I'm going to select chamfer. You can see it did the whole thing because it's a tangent continuous edge. So that will give this a nice feel to the fingers instead of a sharp edge. And the other thing I want to do is on the back side here, I think I'm going to do a chamfer again on this, just for continuity. But I got to come over here first and hit OK. We're not done creating this one yet. I didn't hit OK on the left. There we go. It's adding these moves to our tree over here, as you can see, fillet, chamfer. And we're going to add another chamfer to the inside here. Since those are the same, what we can do is we can take this chamfer that we created, I'll double click it, and this is the edge that it's on, and I can hit select, and I can choose this edge, and that will add the other, and I'll hit preview, and there we go. Might as well just leave it in one move so we don't have too many extra steps in our tree. Come up here and hit OK, Kevin. Don't forget that. Poink. And that's basically our knob. We're ready to print it. But I want to do one more thing just to make it pretty. I think I can actually reduce this diameter just a little bit. This might be a bit big and chunky. I'm going to reduce this diameter. So that's our standoff right here. And if I look under the standoff, here's the sketch. So I'll double click that. There's our sketch. Let's take this down to 13. Hit close. Everything recomputes. There we go. What do you think? Yeah, I think that's better. And I'm going to do one more thing. See this circular edge here? Just to give it more of an analog feel, I'm going to add a fillet. Just to make that look a little nicer. Because why not? We can, right? I go to 2. Yeah, I like that much better, don't you? Let's go with that. In fact, what if we do this? Too much? I don't know. It gives it a little Bakelite look, you know, a little more analog feel to it. What do you think? We can always go back in and remove it later if we don't like, if it doesn't look good when it's printed, or if it's not strong when it's printed. But I think it'll be all right. Let's go with that. So there's our knob. Let's export it and print it, shall we? It's unnamed right now because I didn't save it, so I'm going to save it. Tutorial files, and we'll call it potentiometer knob. Okay. With the body selected in our tree, we go up to the file menu and we export. And we put it in the same place. Tutorial files, yeah, okay. Potentiometer knob body, STL, which is the mesh that we'll use for our 3D printing. Save. And we are ready to put it into Prusa Slicer and send it to the printer. I'll add this to the bed, desktop, 3D printing, tutorial files, potentiometer knob. There he is. Looks pretty good. I'm going to use variable layers. What that'll do is it'll switch to a smaller layer height when the curved areas are hit. And when it gets to the flat areas, it'll go to a larger layer height, and that just sort of optimizes printing time while making the model as smooth as possible. And if I look at the bottom, we've got plenty of contact surface here, so we're not going to worry about it lifting off the bed. Let's print it. So here we go. Here's our potentiometer. Here's our finished knob. Looks nice, doesn't it? Let's see how this fits, shall we? Oh. 4.3 was a little too big. Well, the 0.3 of a millimeter clearance was just a little too big. It slides right on there real nice. And it feels really good to the fingers. We just have to make that center hole just a little bit smaller. So here we are back in our design. So we want to make that hole just a teeny bit smaller. So let's go down here, and this is why we rename stuff. Shaft pocket. That is where the shaft goes. So under there is our sketch. Double click it. Here we are. And we'll just reduce our diameters, our dimensions slightly. So this dimension here, the full diameter is 6.7. We'll take that down a tenth. We'll make that 6.6. Okay. And then this is 4.3. We'll make that 4.2. That should tighten things up just enough. And I'll hit close, and we're done updating. Just that quick. That's the beauty of a parametric program. Man, that's so easy. In Tinkercad, it would have taken a little bit longer. I would have had to ungroup and then change dimensions and then change dimensions on the cutting part and then regroup, and this was so much easier. So we'll come up here and we'll just export the body again, and we'll go and reprint, and it should be good. Here we go. Reprinted with our slightly smaller D channel. Let's see how it fits. Yep, nice and snug. There we go. I'm ready to install my potentiometer, and I've got a knob for it. That was easy. So there you go, my second FreeCAD tutorial. I hope you found that helpful, useful, and interesting, or at least one of the three. We'll see you in the next video. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.